It's crazy to me that we can use the same tool, the same machine, the same material, and we can get radically different results with our chips. Tell me a bit more about how that happens, Jeremy.
So what's going on here basically is we're starting with a low feed rate, basically 0.8 millimeters per rev. That's also wrong. Holy cow.
Big number right there.
Big chip right there.
Big number better.
That sounds professional. So we started at about 80 microns per rev and we ended up at 200 microns per rev. And you can see the huge difference from the starting point to the ending point. Essentially what's going on is we're not feeding the insert hard enough to roll the chips to make them break. So we went up 20 at a time to kind of see where our variances were. We found that about 40 microns is where it changes greatly. So 80 was our starting point. We had just a huge mess of chips here. Definitely do not want this in your machine. And then we moved on up to our 120 millimeters per rev. And we're starting to get some tighter pattern here, but it's still not breaking. Definitely not ideal here as well.
And that's due to the higher speed causing the chip breaker. You can tell that that's starting to engage a little bit more just because of that tighter pattern.
Absolutely. This tight pattern is what you're looking for right before the chip breaker really engages and starts to work. Specifically, if you look kind of in this area, how much tighter this little section is here than say the bottom half of this.
So that's a great way to tell that your chip breaker is on the right track.
Absolutely. So up 40 more microns to 160 microns per rev. What we're looking at here is we're finally getting breakages. The pattern of the spiral is still about the same. However, that breakage is going to prevent tool wraps, part wraps, or any kind of conveyor problems. We went on up to our 200 microns a rev. Here we got some small chips. This is really what you're kind of looking for as far as like not being able to wrap your tool or get stuck in your machine, things like that. Personally, I think I would probably stick around this range here, maybe somewhere right in between. You can see a little bit of discoloration here. That extra heat may cause a little bit of tool life issues. So maybe somewhere between these two would be perfectly ideal, but we're definitely getting right on track around the 160 microns per rev.
So how can you tell that there's a bit of extra heat generated in those smaller chips?
Usually on the color. So if you look, you can kind of see the edges also look almost serrated, I guess would be a good word. You have that extra heat. So you have different color plus serrations of the chips.
And that can negatively affect your tool life, yeah?
Absolutely. Just extra heat would mean tool life can go down. How drastically can depend on the material, but there will be a difference.